Hello everyone, welcome to NS Codes. For the last year, there's been mass layoffs in tech. Now that the economy is starting to pick up just a little bit, this means as you get your new job, you're going to face a very common problem. And that problem is, how do you start working in a hot garbage environment? I'm kidding. The new code base that you're about to work on isn't hot garbage, but it's new. There may be standards that you're not used to. There may be code that you don't understand. How can you step into a new environment and write code effectively without introducing risk and being a good professional programmer? On this episode of NS Codes, I'm going to show you how. We're going to use a code kata called the GildedRose, and we're going to look at how we can implement changes into the GildedRose as if it were a new environment. This video may run a bit long because there's a lot of code involved. Well, actually, a little bit of code involved. However, if you follow through, you'll be better prepared to implement code in your new environment. For this kata, I'm going to use GoLang. You can actually download the kata in almost any language whatsoever. You can download the kata in any language. Just go to the GitHub and you're going to see the GildedRose has been implemented in, I think, every single modern language and a bunch of old languages. Let's get to the code. I have the code up in Visual Studio. This is the GildedRose code kata. I'm going to go through this code briefly for you before we start talking about the changes. There's a requirements text file that you can read. The requirements is more for actually implementing the kata itself. We're not going to implement the conjured method. You can read through this requirement specification and understand what this code base is supposed to do. Let's start by actually looking at the code base before we make any changes whatsoever. We have an update quality method. We have an item struct. I'm going to scan slowly, so I apologize for the screen moving. In the update quality method, you can see that we iterate through a bunch of items. You can see that there's a very complex if statement with multiple paths. You can see that after that if statement, there's more if statements. More if statements. What this is telling me is this method has actually been developed over time. There's another thing that you may notice that's completely missing, and that's comments. You can't see anything that's going on. Okay, maybe that's not a big deal. Let's check the unit tests that have been provided with the GildedRose. Oh no, this is really going to be some hot garbage. Well, let's see if it even runs. Well, the only test available fails. All right. I am actually going to comment out this test. Well, I'll comment out in a second because I don't want GoLang to eliminate my imports. So let's ask ourselves the question. If we wanted to come into this environment and update this code base, how could we do that? What would be our first steps? Well, what you have to realize is often when you go into a legacy environment, there's not a lot of documentation. The code itself is documentation. This means any change, even a fixing change, could be a breaking change. And what I mean by that is, you notice that we have the requirements.txt file. That says what we think the application's doing. But that doesn't necessarily say what the application is doing. And what the application is doing is defined as correct. This means when we implement changes, we can't change what the application's doing, no matter what the requirements actually say. That's critically important whenever we go into a legacy code base. How are we going to ensure that? Well, we need to write some tests around our bounds. We need to write tests around the update quality method so we know any change that we do is going to be reflected and retained with the old information. All right, so how are we going to do that? Tough. I'm not going to write an update quality method. I don't think that's appropriate. Instead, I'm going to look at the requirements document. And I'm going to realize from this requirements document, let me open up the requirements document. What we need to test is a rule-based system around several types of items. The types of items that we have to write tests on are aged brie. We have to write tests on backstage passes. We have to write tests on sulfurous. And then we have to write tests on generic items for the rules. And we know about the generic items because when we look at the actual test fixture provided at the root, which I didn't show you yet, there are some random items. So we know there's random default items. We know there's aged brie, sulfurous, backstage passes, and conjured items are going to be new, but we're not going to touch conjured items yet. We are going to want to write unit test for generic. We're going to write unit test for backstage passes. And just so you know, I've actually done these tests ahead of time to save a little bit on the typing here. I'm copying and pasting right now to show you what we're going to do before we actually do it. We have these tests. They don't do anything right now, but we can run them. Well, if I actually save the file. Excuse me. Now, what I like to do before I write the test is I'm going to go in and state my assumptions at the top of my test. For example, aged brie, once the sale date is passed, quality degrades twice as fast. The quality of an item is never negative. Aged brie actually increases in quality the older it gets. And the quality of an item is never more than 50. Okay. Now we'll go through and write that test. I'm going to copy my basic assumption in. Always does this with me. This is one of the things that I really do not like about GoLang. And that is GoLang will remove your imports every time you save if they're not used. And it makes it really difficult to write debug code. Okay, so now I have my assertions. I really like using assertions. I'm going to run this test. And you can tell my test passed. Fantastic. This isn't the complete test. I just want to discuss something really interesting here, and that is if I were to read what I think the requirements are and then implement the requirements based on this rule, do you think our test would pass based on the code? I already know ahead of time it doesn't, or based on my interpretation it doesn't. And that's kind of interesting. So what I'm going to do is I'm going to show you a case where this may not work. I'm going to change the quality here to -100. And we already know that the quality can never be negative, right? So let's see what the unit test says when I run this. It failed, but it failed with a -99. Which means if I write it this way, this test will be successful. That's very interesting. The quality can never be negative, and yet we just wrote an example where the quality is going to be negative. So we already know that the code doesn't match the requirements. That's a major red flag for us. This means instead of using the requirements as the Bible, we need to use the requirements as a guide in writing these tests. And that's what I've done. I'm about to copy and paste all of my tests in here. I just want to demonstrate to all of you that, well, the real world is the real world, not the ivory tower perfect world. There's my sulfurous. Again, copied and pasted what I thought the rules should be. Backstage passes. And our generic item. And because I'm not going to run a hot garbage test, let's get rid of this hot garbage test. Now, do my test pass? I hope they do because I tested it before I clicked record. All right, all the tests passed. Now what? What can we do to start writing our code in a safe manner? Let's go back to the code base. I'm going to introduce a concept called the spring fig architecture. What a spring fig does is it grows on top of an existing ivy and slowly replaces that over time. And this is a very safe architecture that we can use when we want to develop new code. For us, that means I don't want to touch this update quality method. In my mind, update quality is hot garbage. However, I am going to type a small, tiny update. And that is, I want to write a method for refactoring. What I want to do is I want to pull out this logic here and see what happens. Let's see if there's a built-in refactor. Not in Visual Studio Code, so we'll have to do this the old-fashioned way. Cut out our legacy rule base, and let's create a new function. Update legacy item. And now, because this is in GoLang, we're actually going to put this legacy item onto our struct just to be convenient. And I'm going to replace this array with looks good. I'm going to call item.update. And then I'm going to call the unit test, see what happens. Everything passed. Well, let's double check. I'm going to comment out this line of code, and now let's call the unit test, see what happens. Everything failed. Okay, great. You never know. Sometimes there's a little error in there. So we have our update legacy item method. So now we understand how to update this legacy item. Now, how are we going to implement new item rule sets? And I like to do the new item rule sets because they're separate and segregated. And the way I look at writing refactoring is every time I get a new requirement, I'm going to make a new rule set that's completely segregated from this legacy item. I'm never going to fix the legacy item rule because that's legacy and it's deprecated and we know that it doesn't work. So let's make that comment here so we don't forget. Hey, never change this code. It is legacy hot garbage. All right, how are we going to do that? Well, I want to create a method that will make this decision for us because, again, we don't want to, how can I say this? We want to change the minimum amount of code possible every time we make a change to the code base. This means I don't want to, I'm going to scroll, I apologize. I never want to change this method again unless I'm changing the logic of this method. And right now, if I add a new rule set, I have to change this update quality method. I don't ever want to touch update quality again. It's a well-written, tight method. It doesn't need a lot of changes. So to support that, I need to create a generic method called update that can handle the update rule sets and not handle this loop rule set. I'll do that. I'll just call. Sorry for all the scrolling. I really want to put this method right here. I don't know why. It's just my brain likes doing things this way. Now this update method we'll just blindly call that the update legacy item. Now, if I run my unit test, everything passes. Lock this down. I'm no longer going to have to touch the update quality method. Now, instead, what I need to do is update new rule sets as the new rule sets come into existence. What's an example of a new rule set? Let's see here. Let's do an aged brie rule set. No, wait, I'm not going to do aged brie because I didn't write aged brie. I actually wrote the update sulfurous taking into account the legendary rule set. So let's implement update sulfurous. And now we can write rules inside of our update method to determine which method to call. Okay, great, great, great. I wish it were great, actually. Why? Because if we look at the old code, the method for determining the item type, I just don't like. It's built in to the method itself and it's not segregated. This means I really want to create a segregated item type method. That means that, and the reason I want to do this is I want an item type method that's testable and always works, and I don't have it embedded in my actual logic for other methods. So let's put a pause here, or a pen in this, as people like to say, and let's make an item type method. I'm going to go all the way to the top of my class file, and I'm going to create an enumeration in GoLang for item type. My item type is aged brie, sulfurous, backstage passes, and I don't know what's going on. And now I will copy in the code. Need to add the strings import. Sorry, I'm getting jumpy on you. It's not fair. Great. That's finished. No, that's not finished. Why isn't that finished? That's right. We need unit test to test this. So let's go add our unit test for our item type. Excellent. It works. And again, let's just see if it works if I comment everything out. No, fails. Okay, good. The reason I like this is as we implement the rules, we're going to understand more about what makes an item type. What makes an item type. For example, looking here on line 21, let me highlight line 21 for you. Notice that I wrote the rule for backstage passes as actually just having the phrase backstage passes within the item type text. However, let's scroll down to our legacy code base real quick and notice that backstage passes is actually hard-coded to the complete backstage pass here. This means the legacy probably won't work for other backstage pass types without being reprogrammed. That also means that my new code doesn't work with this legacy code base. Interesting. All right, we have item type. Great. Now we can update our update method. How are we going to do that? We're going to get the item type of our item. And now we can call update sulfurous. I hate this word because you even notice that I misspelled it here. And let's run our test again. Well, that's interesting. My test didn't fail. It should have failed. I wonder why it didn't fail. We're calling this update. We check the item type. We've updated the legacy item if we don't know the item type, and yet it still failed. This is telling me that maybe I'm not checking the item type correctly for sulfurous. Oh, you know what? I bet I just didn't save the code. Oh. No? Definitely going to cut some of this out. I'm going to leave this in. I'm going to leave this in. All right. I'm going to tell you exactly what the problem is here and why this is a very poor example for me here to update. What happened was the sulfurous rule actually doesn't do anything in the legacy code. Let me scroll the legacy code real quick. It says it does something. But when you actually look at our unit test, we'll notice that nothing changes. The sell-in's not updated. The quality's not updated. So none of the rules actually take into account for sulfurous for some reason. So it's like literally the worst item to implement new code for because you can't tell if it run or not because it's not needed. Oh, yeah, that's crazy. All right, let's implement one that will actually do something then. Let's implement, generic. Wait, let me see if I've actually implemented another one first. Okay, let's implement the generic updater. The item type that we just written, if item type what did I call it? It wasn't generic. Unknown. Great. Our tests for generic have now failed because we're not calling the generic. Now we need to implement this method for updating our generic item. Our test still fails. All right, great. How do we do this? All right, what were our rules? Does anyone remember the rules for generic item? The rules were quality cannot be greater than 50. Never more than 50, okay. If sell-in less than 0, then decrease by 2, not 1. Excellent. And every day decrease quality by 1. All right. I'm thinking here for a moment how I want to implement this. I don't know if I like it this way. Still failed. What rule did I write wrong? Oh, it's always something silly. There we go. We've passed. We've now successfully implemented our update generic item. Using this strategy, we can easily write new code into a legacy code base without introducing a lot of unnecessary risk. I know it's laborious, it's time intensive. The results are well worth it. And when you write code like this in a professional environment, you're going to be seen as a professional programmer versus an amateur hacker. This method is a simple method that we can use whenever we inherit a legacy code base so we can safely make changes in a constructive manner without having to rewrite the entire system at once. Questions, comments, put them below.